So if everybody is finding a seat, it's time for Konstantin, who is well known for stuff like Sinatra, other open source projects, and recently Travis. And he's going to teach us something more about HTTP.
Hi everyone. Oh, it's on. Nice. I'm going to talk about HTTP. It's quite full now. A few minutes ago, I assumed no one was showing up, so I thought like everybody probably knew HTTP already. So I'm not actually going to talk about what HTTP is, because I assume that you all know what HTTP is. I actually want to talk about some things in HTTP that we might not have really thought about when we build applications. As already said, I'm Konstantin. That's my insanely long Twitter handle. In case you're not following me on Twitter. Also on GitHub. You know GitHub, the sticker company? Turns out they also do code hosting. And I'm just RKH on there. I do Sinatra, Ragtill, Robinia, some other stuff. And to do even more advertising, last year, together with Alan Harris, I also wrote a book on Sinatra. This is an amazing discount code that gives you 50% off the ebook, so it's $650 US. That's about €3, so about a doner kebab in Berlin. I also have cards, if you don't want to write that down. I work at Travis, and I have to do more advertising because we are currently donation-based, and we have some amazing companies that donated money for us, so we can work on this full-time, do open source. Okay, enough with the advertising. Let's talk about HTTP. If you've spent more time looking into HTTP details, you might be familiar with RFC 2616. That is the HTTP 1.1 specification. Right now, if you do HTTP, this is basically your Bible. And we want to look into what that has to offer to achieve certain goals we have when we develop a website. One of the goals is performance. We really care about performance. We just heard you should be below 50 milliseconds for your actions. The other thing is scalability. We should be able to do that for millions of users, potentially. And which is also really important is security. We don't want all our passwords to leak somewhere or to have people gain access. And since Web 2.0, that's no longer a thing, right? Cloud and everything is connected, we also want interoperability. So let's see what HTTP has to offer. And if we look closely, it actually turns out that HTTP has been made for this. We just don't know. So how do we build websites right now? We build websites pretty much the same way that we used to do when we still had Perl files that were called .cgi. That is, we do have the server, used to be Apache, now it's Heroku, it's some abstract thing dealing with the HTTP, or not abstract, but we usually don't care too much about it. That sends a request to the application then loads something from the database, generates a response from that, and it goes back. And everything basically happens within this response request cycle. Now, what happens if we want to scale that? Well, the first thing we can do is we can add more application processes servers, virtual machines, dynos, whatever you call it, and scale it on that layer. That will get us some way, but it might still not perform extremely well. So we can scale at the database level. Add more databases, master-slave, whatever fancy NoSQL stuff you have. And that will buy us performance and scalability again. But what if we reach the point there? Well, the sensible thing is to add a cache. Rails.cache, everything's fine. Works well, so let's do that in front of the application. More performance gives us some way, and then again, at one point we want to do more caching, like elaborate the browser cache, or intermediate proxies, whatever. More performance, but still we might hit the point where we just can't get any faster. We can optimize the business logic by adding caches within our logic. See there? And probably a lot of people that do Rails development end up with an architecture similar to that. So if you should ever draw a graph like this of your application, there's one thing I want you to do. For the caches, use Comic Sans. I'm not saying caches are bad. I'm just saying if your application has to rely on caching to be performant, to scale, then you might run into big trouble once you hit the point where you can't go any further. So how do we scale further from here? I don't see much space to add more caches. Let's look at the specification. The specification talks a lot about requests, resources, and representations. If you have a normal HTTP request, you've probably all seen that. HTTP actually is a readable protocol, which has upsides and downsides. Then you see this all is the request. It requests the resource / and this is the representation of that resource that it takes. And now let's try to optimize our architecture for requests. The first thing we can do is we can add persistent connections where we reuse the same TCP connection so we don't have a slow start. We can do pipelining. We can do crazy stuff like Speedy, where we use one TCP connections to send a ton of requests at the same time, which will probably make it into HTTP 2.0. And we can all do that without changing our architecture. But again, that will only take us so far. That will mainly optimize performance and not scalability, actually. So let's try to optimize the resources instead, or rather, in addition to this. That's what I call RFC 2616, the good parts. It's basically everything in the specification that's not a must, but a should. That's how you realize what you should be doing. I assume you all are aware of HTTP verbs, methods, like get, head. Options trace are pretty not that common. Put, delete, post, and patch. And I grouped them in those up here are what's called the safe verbs. Those down here that are the idempotent verbs or methods, and those down here are the unsafe methods. You probably all have heard that in discussions, and it's also important for CSRF protection. But what does that actually mean? Safe means it's repeatable. Means this is our system state, like in a state machine, state number 1, and no matter how many requests we do, it always ends up in that state. It's also we can judge from the request without sending it what the system state will be afterwards. So it's deterministic. All is good. And next come the idempotent methods. Those are actually methods when I send an HTTP request that change the system state. And that's not good. We don't like the state change. State change is hard to optimize. But it's repeatable, so no matter how many requests they're sent, it's still the same state afterwards. It's deterministic. Same goes for delete. Patch is a special thing because patch is not repeatable. That's a new verb. Rails 4 will have built-in support for that, which actually, if you have a common understanding between the client and the server of what the body means, can be a diff or something like that. There are proposals for JSON modification, syntax. It actually is deterministic. You know that if your state is one of the resource or of the system, then after you apply a patch +1, it will be 2. And both the client and the server can assume that as long as they know what the patch content means. So at least it's deterministic. And now comes the bad, evil method we're all using for everything. That's post. It's not repeatable, because if you do a post again, you don't know what will happen. It changes the state or does not, and it's non-deterministic. That's actually the definition of post. Post is anything. So to summarize this, bad, okay, better, best, when it comes to scalability, optimizing for that. And in that case, depending on how you structure, like, carry on with me, you could claim that a patch, in the worst case, is a lock on the document, because you need the document. If you assume that those methods are like functions, then as input you need the current state of the document and the request body, the request. So it's basically like a lock on the document and a put. And post, in the worst case, is like a lock on the system, because all system state could influence the outcome, and then a put. So let's try to build an architecture like that. Let's try to have resources as first-class data. So what we can do is we can store our resources somewhere in some representation that we understand. And in front of the storage, we can have a renderer that basically takes the request, understands the request, and then decides how to, if and how to render the resource, transform that into some understandable representation. In the best case, where we just have a public website, that can actually, the renderer can be a web server that serves static files. The renderer can be something smart, anything you build, can be from your web framework, can be whatever. And then you can also have your business data, your normal active record object or something. If you have a simpler website, then your resources could also be your business model. And if you see what has to be done within a request, that actually goes from request plus business logic plus database access plus rendering to request plus database, file system, whatever access plus rendering. And that gives us enormous performance. Let's check out how we can scale that. So the first thing we can do is we can have more than one renderer, which is basically the same thing as having more than one application. What we can also do is we can have more than one process taking care of our business logic. We can have more than one resource database. And any guesses what the last step is? We could split up our business data. And we can, of course, have more than two of these. And you might see that, for instance, right now, so what we have to care about is how we synchronize, because those stacks are now completely separate. How do we synchronize them? We could basically do that on any level. We can use the HTTP level to do that. So assume you have one load balancer in front of it, a smart load balancer, to distribute a GET request or any save request. We just have it to send it to one of the boxes. That's basic load balancing, everyone knows that. If we now get a put request, what we could do is just set the put request to all the boxes, because it's deterministic, it's repeatable, that should work. If we get a patch request, we just send it to one box that decides what the resource looks like and then does a put to all the requests. I'm not saying you have to structure your app like this. This is just some architecture things you can think about that you can use when you have HTTP. And now, the big downside is, what the hell do you do with a post? And that is really dependent on what the semantics of the post are. HTTP basically has none. It's your wildcard method. So there you will need a lot of business logic somewhere. And of course, there are some other issues like the browser support for HTTP methods is not great. You have to cheat around that. So you basically, your front-end server has to do tricks to translate some requests. Basically, all your browser will usually send you as a GET or a POST, and there are tricks to translate POST into something else, because this is invalid HTML, and that's just something I made up. But you see what I did with the patchwork? I actually said something about locking. Locking, HTTP. Also locking. I heard locking is evil. So let's do optimistic locking instead, because that's optimistic. We all know the methods for optimistic locking actually from browser caches. There is the if non-match method header that will ask for an e-tag, and if that e-tag is the e-tag of the resource, then the server will, instead of sending that resource, respond with 3 or 4, everything's fine that you have. You can actually use those headers in other ways. For instance, you can say, just perform the patch if this is the state of the document. This identifies the state of the document, and it can basically be anything you want. And then, if that's not the state of the document, the server will respond with a 412. You're doing stuff wrong. And there's even more. Besides the if match, there is, as I mentioned, the if non-match. But did you know that you can apply an asterisk to that? And the asterisk identifies any e-tag, meaning that the resource exists. So this put should only be performed if the resource does not exist. Since put is an absurd, that is not really doesn't make that much sense in that case, but you get the idea. You can also use that with a patch, with anything else. And you can do the same thing for if match. It means only perform this action if the resource actually exists. You could do only add 1 to this counter in my super awesome counting HTTP API if the counter actually exists. And in the same way, you can use if unmodified since, which is the counterpart to if modified since, which you use for caching. And again, one of the issues is there is no real support unless you write everything in JavaScript, there is no real support for that in HTML. Like, how awesome would it be if a form could just include the e-tag? But in general, if we play with that kind of things, that gives us scalability. Now let's talk about security. And for security, I'm going to take an example attack. I gave this talk once before, and basically all the questions after the talk were about this attack. This is an open vulnerability in basically any, like most web apps out there, including Rails app, including a ton of Sinatra apps, but it's not that bad because it's fixed in all modern browsers. So if your customers are using Firefox 3 point something, then I would be worried about this attack. And it's just an example on how you use such an architecture to prevent the attacks. The attack I'm talking about is the JSON cross-site request forgery. Basically, you're vulnerable to this attack whenever you have some JSON API you're using internally, and for authentication you're using sessions. Raise your hands if you're using internal JSON APIs in your Rails app, web app. Everyone else is not using JSON? Come on, no one's using JSON here. And keep the hands up. Keep the hand up if you're using your session for authentication. Okay, if you use cookies for authentication. Like the normal Rails session. Only 4 people, 5 people? Okay. Anyway, those 5 people, you should pay close attention. Imagine you have some internal API that loads an array of things you need to display. Imagine your GitHub and you load the list of private repositories or commits to a private repository or the content of files over an JSON API. Now, GitHub is invulnerable against this attack because GitHub doesn't do that. But just imagine that. Seems pretty good to me, authenticated, and the same origin policy actually protects that JSON, so an attacker can't load the JSON, right? Seems all fine to me. Now, what an attacker can do, though, is embed that JSON as JavaScript. This works, but still seems pretty okay to me. Like, basically, this circumvents the same origin policy, adding that attribute says ignore what the content type is, just assume it's JavaScript. And then this will be run as a JavaScript file. Still, no harm done, right? But assume that would do harm, then what you see is that the browser doesn't really help us. I tried to fix that generically for Sinatra, and all the browsers send you that as accept header, or like the standard accept header. They don't tell you, oh, I was told I want JavaScript for this, so there's no way to detect that it's actually embedded as a script. Now, the funny thing is, in browsers that do not have an explicit patch against that, you can override the array constructor. And if you do this, if you do override the array constructor before loading the JSON as JavaScript, then your custom constructor will be called when that file is executed. And then you can just you can access the objects in the array and write them somewhere. You could send them to a server and get all the secret data, which in our case is just chunky bacon. And this is actually an attack really, really hard to protect against. I have a repo on GitHub where there's just a simple Rails app where it runs that attack. You obviously need an old browser, but it works like a charm. So imagine Rails trying to solve this issue. What could you do against it if you're like in a generic way? With the old application architecture, what you need to do, the standard approach for preventing CSRF attacks but not breaking APIs, is to remove the session before the request. Now the big thing is you do not, since this is a GET request, you might need the session because it might be the proper request from your website. So what you could do is you could look at the response, because you don't know upfront that the response will be a JSON array. So you could look at the response after processing it and then just send the request again without the session. But that would mean you fire the request twice. And since we don't follow the should parts of HTTP, that might actually cause some harm. Or, well, even if it doesn't, then it will just increase the server load. But if you had a concept of resources, then you would know up front, for instance, that, well, this response is going to be JSON, it's going to be an array. Let's just be on the safe side and not send the session with this. And there's a lot of stuff that you can do like this to prevent, especially cross-site request forgery. So an architecture like this gives you a lot of security. Now, there are other things to do against that specific attack, because last time a lot of people asked me, I have this normal rails application, what can I do against that attack? Now, when I wrapped up the demo, I actually tried to find a real-world target. So I looked at GitHub, I looked at Facebook, I looked at Twitter. What can I do against that? Interestingly, the one site that had constantly issues with this attack is actually Facebook. Facebook, up until a few months ago, was extremely vulnerable against this JSON attack. So let's see what they're doing and what's the best way to do this. The first thing GitHub does, GitHub is invulnerable against that attack, I assume, by accident, because they're simply not using JSON. You probably have heard about PageX. Have you heard about PageX? Yeah, it's basically, you do everything as static HTML, but then you don't, it's a lot like turbo links, except you don't load the full site, you just like extract a part from the DOM from the site you load over Ajax and add it to the DOM that you have right now. And that's not JSON, so you cannot run it as JavaScript. Then what Twitter does is actually, I think, the right way to do it. They simply do not use the session for authentication. What they use is they store the token, so it's I'm not sure what they're using, if they're using local storage or something. They store the token on the client side, like OAuth token style, and send that with an authorization header with every request they send out to their API. Interestingly, you can also use that to dynamically load HTML. It doesn't mean that you're bound to JSON, but it also means that any other evil attacking website cannot trigger requests that will include this header. This is also where we're moving with Travis, with our rewritten JavaScript client, and that interestingly protects you against basically any CSRF attack out there. That's including the crime attack. Have you heard about crime, the SSL attack? Basically, if you use SSL, then your session can still be captured from someone who only sees the encrypted stream. But to be able to do that, they have to be able to trigger meaningless authenticated requests to your service. If the browser doesn't authenticate all the requests, then it's just impossible for them to trigger these. So they cannot capture your session cookie. So this gives you security and protects you from Mr. Evil Hacker Dude. What's missing? Interoperability. I mean, HTTP per definition is interoperable, but if you want to take it further, we have hypermedia. just as one thing for interoperability. There are other things we can use. There is fantastic stuff like XML, RPC, SOAP, all those great technologies you can make use of to get generic interoperability. No, I'm just kidding you. If you don't have to, do not use SOAP or XML or RPC. So that solves interoperability. So I highly, highly encourage you to read RFC 2616. Think about the shoulds in there. Not everything is good, something is vague, but some things, like, there are also good advices in there. There's also stuff for security considerations. And think in terms of requests, resources, representations. And I think that was quite a quick run through. I think I have 10 minutes left for questions. Yehuda. Yeah. That would still be fine. Basically, the whole point is just don't look at the cookie. Yeah. Yeah. Exactly. More questions? Or remarks? So that's a real... So in general, that's a problem. That's what I meant with lack of browser supports. You don't have this. So there are things you can do to fix that. You can try to use the origin header, but then you will even get into more trouble with browser support for old browsers, for legacy browsers. So generally, browsers are now... So what you could do is you use the referrer. So if you have an HTTP request, then sometimes you get a referrer header that says where the request is coming from. Turns out that's not reliable, because there are a ton of scenarios where that is not sent for security reason. Like if you come from an HTTPS server website, then the referrer is not set, because the referrer in general could contain confidential information, like from an OAuth handshake or something, and then you get the token. It's also not set if you're coming from FTP, and so it's really easy for an attacker to build a scenario where there's no referrer header, but you cannot trust that because the request could come from your side. It's also really easy for an attacker to fake the referrer header with outdated Flash versions, for instance, or some smart, using some vulnerabilities, like if you have a generic redirect stuff. So browsers are now supposed to send an origin header, just including the schema, host, and port, which is also part of the cross-origin resource sharing specification, which you can use to make JSON requests to a different host. And in theory, that is way more trustworthy. But in practice, first of all, most browsers don't implement it. Most outdated browsers don't implement it. Most recent browsers do that. And there are also some scenarios where it's not sent with the request sometimes, especially if you are one or two versions back in Firefox or Chrome. Then sometimes if you do JavaScript embedding, there's no origin header. And also, again, that can be spoofed with broken plugins, like a broken Flash plugin or outdated Flash version. So, long answer short, this is actually a really hard topic. It is actually something, most of you don't see that because there are a ton of, like, all the Rails core developers have to take care of that. Yehuda did a good talk about that at Railsbury. All the stuff that you're not aware of, that you don't see that's going on there. Like, why is Rails slower than Node.js? Because in Node.js, I don't want to start a flame war or anything, but in general, there's so much stuff going on, and when it comes to security, most developers are not aware of a lot of attacks. Everyone's aware of cross-site scripting. Most people are aware of the normal CSRF attack by now, but like you read there's some SSL attack, but who can explain to me how crime works? Yehuda? Right. Yeah, like for normal post requests, you can add that with a hidden field that includes a token, and then you check the token against the token that's in the session. And if it doesn't match, then you know the token's coming from somewhere else. That's what Rails gives you right now, and that protects you against the normal CSRF attacks. And in contrast to, for instance, like Sinatra gives you that too, but you need to add it manually to your form. Otherwise, Sinatra will just reject the request. But Rails does that all magically for you behind the scenes. More questions? Anything not security related? Anything security related? Anything about my awesome hat? Okay, so time is nearly up now. One more add thing. So Travis CI, who in here uses Travis CI for open source? Some. Who in here would like to use it for their private projects? Okay, we are going public in hopefully 2 weeks. Maybe more, maybe less. I don't want to announce a fixed date yet. We're going to start charging. If you follow the Twitter activity, then you might have noticed that some companies are already paying. If you want to check it out, and if you're willing to start paying before the official launch day, I have coupons for you that will make it cheaper. And I'll help you set it up if you come to me. So you can start using it for your private projects right after this talk. Thank you.
So we have lunch down